How do senior engineers practice coding to keep their skills sharp?
That's like a cardinal sin when approaching problems for actually doing interviews. I know people say like you don't use LeakCode in work, but sometimes you do, right? Sometimes you need an LRU cache that you have to build. So this is the merge sorted array. Ended up at Lyft, which was a goal of trying to do something at larger scale. Constant space complexity, which is what we want, and linear time complexity, and really having like a deep knowledge of what you're doing, because this actually affects millions of people that you're now responsible for. This is practice, so it's about developing the patterns and recognizing them. But the fact that it came back so quick means that the retention is there. The boot camp doesn't teach you that. When people approach these problems, there's the normal suggestion of what I heard was,
I'm Kylie. I'm a web developer with over 10 years of experience, and I spent the past 3 years at Amazon Web Services as a senior front-end engineer. Today, I'm going to be sitting with Dylan, a former colleague of mine, who is a senior engineer at Lyft. And we're going to be working through some code problems, and you'll get a sense for how Dylan practices to keep his coding skills sharp, as well as some of the thought processes he goes through when he's solving code challenges and code problems. So let's dive in.
hello, everybody. I'm Dylan. I've had a interesting journey into tech. I would say it's my second job where I actually met Kylie, working at a consulting firm. My traditional background was not in tech. It was in sports psychology. And long story short, I was running a basketball camp and clinic for kids, and we needed to modernize how we took our payments and how we scheduled things. And so that led me down like a WordPress rabbit hole and spec element on Google. And I was spending like 10 hours a day building out that process, knowing nothing. And I kind of developed a passion for it. I joined a boot camp, and the rest was kind of history. I just fell in love with it, developed a passion for kind of using a different side of my brain that I hadn't used throughout my life. Joined a few consulting firms and startups along the way, and ended up at Lyft, which was a goal of trying to do something at larger scale. And something that we kind of saw in the consulting world is that you build things. There's a lot of greenfield projects, this rapid iteration of MVPs, and then you churn it over to whoever was paying for it, and you don't suffer the consequences of the things you built. And so it didn't matter if it was super efficient. It didn't matter if it was bug free, because you weren't owning it. And so this was kind of a push towards accountability of understanding the different decisions you make, and really having like a deep knowledge of what you're doing, because this actually affects millions of people that you're now responsible for.
Yeah. Yeah. And how long have you been at Lyft?
2.5 years, a little more than 2.5 years.
That's awesome. So then would you say that working at Lyft has taught you, I mean, everything that you looked for when you were trying to go to a big company with a big code base like that? I mean, have you learned those types of things working there?
Yeah, so they've got their pros and cons, right? Like my very first job I had, it was with a very small startup. It started as an internship at the boot camp I was at. And it was me and two other new grads. And then the founder. And he was like a 20-year vet. He'd worked at Wells Fargo for a long time, and some other companies. And we had no idea what we were doing. And for the next year, we had no idea what we were doing. There was very little guidance. A lot of it was, setting yourself up for success rather than having a process set up. And so it was a chance for me to learn what I should be learning in order to develop features and ship them. And so very little overhead. And then I moved into the consulting world for the next maybe 4 years, across two different firms. And that was a very large breadth of knowledge. Like depending on the project, you had different technologies. And so you got exposure into all these different things, in different cloud providers. And you could see how there was a lot of similarities across things. And one of the things I learned out of that was the technology is just a tool to solve a problem. And you can choose any number of languages. And some might be slightly better than others at certain tasks. But in general, like I can solve problem A with X, Y, or Z technology. There's multiple different ways to do it. And so I built this large breadth of knowledge. And again, there was process, but it was very short-lived, right? and you try to do it from project to project. But as you well know, different clients have different expectations and different processes they want to do. And so it's not always up to you to decide on what you do. And so once I got to Lyft, I had this very large breadth of knowledge. I wasn't super deep into one area. I had been exposed to a lot of different processes. But at Lyft, it was like a true big tech type of scenario where they had very mature processes for everything. How you handle your code, how you do PRs, how you deploy things. There were a lot of frameworks that were built on top of things that you normally would have to do. And so there's entire teams devoted to improving the efficiency of how you deploy your code. And so for an engineer, I don't have to worry about the CI/CD process. I don't have to touch the cloud providers. I can just push my code and it runs. There's a whole team dedicated to make sure that that works correctly. And so there's a lot of frameworks on top of that, like logging and statting. There's entire frameworks that are in-house built to where I can write one line of code and it propagates to the right, services that let us have observability into what we're doing. And so when I say like there's pros and cons, because I'm building on top of so many mature frameworks, I don't have to know the low level details of how the CI/CD works anymore, which means you lose a bit of that. But it means that I'm almost entirely focused on product development. And so I am very scoped into developing features, understanding the product domain, and being able to build things that actually go into the app that people use. Yeah. And so there's a lot more of dedicated time to work on that side and not the pieces that most people have to do, right? It's like, I want to build the feature work, but I have to do this first.
Yeah.
And so you get a mix of both, depending on where you're at, but Lyft has served the purpose because I had that foundational understanding beforehand of doing all that other stuff.
That's awesome. Well, so today we are going to look at you doing some practice in the way that you typically practice, keeping your skills sharp. So tell us a little bit about how you go about basically making sure that you're keeping that broad skill set that you had before, or maybe focusing on going deep on one particular, topic. How do you typically practice to keep your skills up?
Yeah. So I go through like the common interview pattern of LeakCode style problems for data structures and algorithms. That's usually what I focus on to keep me sharp. And so, and that has benefits of actually implementing into code. I know people say like you don't use LeakCode in work, but sometimes you do, right? Sometimes you need an LRU cache that you have to build. And so the other concepts I think are easier for me to understand just through reading documentation, but pure data structures and algorithms was something I'd lacked in my education, right? The boot camp doesn't teach you that. And so I tend to focus on that as my weakness. And so, I guess there's like the main train of thought is that when people approach these problems, there's the normal suggestion of what I heard was you see some problem and then you don't look at the answer, you just try it yourself, right? You work on it and you work on it and you work on it and you hit roadblocks and you struggle through it. And through those struggles is how you learn. I don't operate that way at all. It just doesn't work for me. I would rather go look at how what the optimal solution is to a problem to understand the core concept behind it was optimal. And so the next time I approach a problem, I'm now understanding the concepts of why this was a preferred solution. Because I think most people would agree that if you're going to build something in a known suboptimal solution, that now there's work to be done to improve it. I'd rather understand the core concepts in the beginning so that when I build something, it's already at the optimal performance.
Yeah.
And so
that makes sense.
That's typically how I address the problems when I'm studying.
Cool. Well, hey, let's dive in and we can keep talking a little bit as you work. This is LeakCode. For anybody who hasn't seen LeakCode before, Leet, L-E-E-T, code.com is a place where you can go practice coding challenges, problems. You'll see a lot of these types of questions in big tech company interviews and small tech company interviews as well. And they usually range from like easy, medium, hard, but they also focus on different topics. So You mentioned DSA, the data structures and algorithms. Is that what we're going to be looking at today?
Yeah, it is.
Cool.
And so, yeah, spot on. Like LeakCode is just a site with many different problems to tackle across many different areas. And so, even within something like data structures and algorithms, like you said, there's easy, medium, and hard type problems, and they cover. You might go into strings and arrays and manipulation, and then work your way towards graphs and trees, and get into more of like a complex scenario to try and solve some arbitrary problem.
Cool.
And so I'll go to something like these problems, top interview questions, and I've gone through some of these already. So a typical process for me is reviewing some of the ones I've already done, and then approaching problems I haven't done. And so there's this aspect of like retraining. So I go back to problems I've already done to make sure I still understand the concepts. And a lot of times it's not even the writing code, it's just walking through it and making sure I understand what I was doing at the time.
Mm-hmm. Mm-hmm.
And I know, because of how I study, what I was doing at the time was reviewing an already solved solution that now I'm making sure I still understand the concepts.
Yeah.
And so, for instance, we could start with the merge sorted array. All right. And so what I normally do is reread the question, and then I'll go look at my code to try and make sense of what I did before, or I'll read the question and then like talk inside my brain of like, how would I try to solve it? And I think that goes to the original concept people have of bash your head against the wall until something sticks.
Mm-hmm. Mm-hmm.
And so we can just go through that now.
And just real fast, I see that you chose Python. Is that because you feel like Python is easier to work with for these types of challenge questions, or why'd you choose Python?
I'm more proficient in JavaScript because I think it's what I've used longer, but Python's what I use more work. And so it's more relevant to what I'm doing. And so if I see some concept, I'm like, I don't know how to do that. It's beneficial for me to know it, because the next time I approach it at actual job, it might be more relevant.
Got you.
Okay, so that's why I use Python now.
Yeah, well, let's take a look at this. This is great.
Cool. So this is the merge sorted array. You're given two integers, integer arrays, nums1 and nums2, sorted in non-decreasing order or ascending order. And you have two integers, m and n, representing the number of elements in nums1 and nums2 respectively. And so we have the length of each array added in as an argument. I don't know why they add those, but they did. So the goal is to merge nums1 and nums2 into a single array, sorted in non-decreasing order. It says the final array should not be returned by the function. And so that indicates to me that we're not going to create a new array. We're just mutating the nums1 to return it. And I think the goal with this is that you reduce the space complexity. You're introducing less in memory by using nums1 as opposed to creating a new array. And so to accommodate this, nums1 has a length of n plus n, so the total length of both of them combined, where the first m elements denote the elements that should be merged, and the last n elements are set to 0 and should be ignored. Nums2 has a length of n. Cool. So going through this problem with a merge sorted array, to do it in an optimal way, I work backwards. And so I take the values from the end, and I do comparisons between the A and the B side, which nums1 and nums2. So if I take the last two values and I do comparisons, if they're greater or less than, it lets me know which one I should actually add into the array. It makes more sense when we look into the code. And so that's my general thought, is I'm going to work backwards from both arrays. As long as I have something in the second array, I know that I can keep going. Mm-hmm. Assuming that everything from the second array has already been merged in, then that means the rest, whatever's left in nums1 was already in the right order. Mm-hmm. And so I'm trying to eliminate all the values that are in the second array into the first one, so that so the first array has everything in it because that's according to the rules, the one we have to return. Okay, so
And Dylan,
now yes.
if you were being asked this question, um, would you typically say everything you just said about how you're thinking about this problem, or would you typically just dive right in and start writing, while b is greater than 0?
Yeah, I would definitely not write the code first. That's like a cardinal sin when approaching problems for actually doing interviews is that you want to talk through number one so that you get clarity on the question that's being asked and you understand the prompt.
Hmm.
Because the worst thing to do is start writing code down the wrong path based on a misunderstanding of what you're supposed to be doing.
Hmm.
Because it's very hard to without just erasing it and starting over, it's very hard to shift what you were doing into a different solution.
Yeah.
And so explaining the prompt and getting a good understanding of what you're doing is crucial for you, but also so that the person who might be interviewing you can follow along with what you're doing.
Gotcha.
So the more I'm very vocal when I go through these problems, and like when I went through interviewing, I do a lot of communication and back and forth because it's supposed to be a collaborative experience.
Hmm.
Interviews are supposed to be collaborative, right?
Yeah.
Like the person on the other end has the advantage of knowing the solution already.
Right.
And so their track of mind is like, here's the solution. Let's see if somebody else can get to that and let me help guide them with as
Yeah.
little oversight as I can.
So this
And
is, just to be clear, this is just you practicing to keep your skills sharp, but you still, even in just practicing, you try to talk it through in your head. You try to think about how you would
mm-hmm.
describe it, what you would say, and before you start writing
Yeah.
your code. Okay, cool. Go
Yeah.
ahead.
And it also, but like I conduct interviews, right? And so
Yeah.
the more experience I get in these different types of problems, it's easier for me to understand because the goal of this is to understand the concepts, right?
Hmm.
Like
Hmm.
sorting arrays, merging a sorted array is a concept that can be used for other problems. And
Hmm.
so if I'm conducting some interview and somebody starts going down this path, it's easier for me to follow along with what they're doing because I know the concept now.
Yeah.
And so it also benefits me from that way. And I tend to take pride in conducting interviews. I want the interview to end and the person to say like, that was a great experience, whether they
Yeah.
did good or bad, to say like, man, I bombed it, but the person interviewing me was great.
Yeah.
Or
Absolutely.
like that person really helped me get to like this final solution. It was optimal. They chimed in at the right time. They were able to follow along with what I was doing. And
Yeah.
so it provides that aspect as well.
Cool. Cool. Okay. Yeah. Well, yeah. Walk me through this a little bit.
Sure. All right. So understanding that like the main idea here is I'm working backwards through the arrays, and I'm mostly focused on the idea that the second array is the one I'm trying to deplete. I'm trying to pull pieces out of that and put it in the first array. And so I instantiate a few variables here. And so I have A and B and then a right index. And so A is going to represent the index for nums1. Remember, M is the number of items, but if we're going indexes, we've got to go back one. And then B represents the indexes for nums2. So now I have the index position at the end of the list for both of them. And then the right index is the total, the index at the very end of my array if I had combined the two. So at the very end, that's the length of my indexes for nums1. All right, so we had mentioned like we want to deplete B, right? B represents the index for the second array. That's the one we want to get rid of and merge into the first one. And so this directly translates to code. So while B is greater than equal to 0, meaning that I have started at some max length and I've gotten all the way down to 0, and that would be the last index. So the moment I go below that, I'm now out of bounds and it terminates the while loop, which means I've gone through all the values in B and they've been sorted. So the next part here is that I have to determine is, between the two values A and B at the indexes that I have saved, which one's larger, because that's going to tell me which one do I need to move. And so I can check as long as A is greater than or equal to 0, meaning I still have some values from that, from A. I haven't worked through all of A. And the nums of at that, or the value at the index of A for nums1 is greater than the index of B at nums2, then I can take that right index, which starts at the very end, right? Remember, I'm working my way backwards. That becomes A because A was larger. And so we are sorting this in non-decreasing order. So that becomes the value that I want to put in there. So if nums of A at this very end is larger than nums of B, then at the very end, I'm going to put wherever that index is, I'm going to put nums of A. And then I'm going to step backwards one index in A. So I've already handled that last value. I'm going to go to the next one. Otherwise, meaning that B was greater than A, I'm going to take that index, the right index, and I'm going to make it the nums of B. So whatever that value is. And then I subtract B. And so just by having those two conditionals, I'm now checking A and B. And whichever one's greater is going to be the one that I put into that, the last spot, or what we call the right index. So where we're actually writing to the index. And so in either case, right, A or B, to identify the next spot in line, we decrease the right index. And that's pretty much it. So you're both basically just checking the values, which one's bigger, put it at the designated spot. And so that's how we're going to merge sorted array into nums1. As you can see, like we're using nums1 as the array. So that's what's in the return, that's what's expected to be used.
Now, why doesn't this accidentally erase values when B is bigger than A? When the item in B is bigger than the item you're looking at in A, and you just replace it with whatever was in B, what happens to the one that was at that spot before?
So if we think about like what nums, nums1 might look like this, right? And then nums2 might, we'll just make it easy. All right, and my right index, when I initialize it, well, let's go through all of them. So A in this scenario is going to be equal to 3, right? M is 4 because I have 4 of these. My index, the max index at A, which represents num1, is 3, right? 0, 1, 2, 3. And the same thing with B, right? These happen to be the same. Okay, my right index is m plus n minus 1, right? So we have 4 plus 4 minus 1. So we're going to end up with 7 here. Okay, so at 7, that gives us 8 values. And if you notice, nums1, what we're basically saying when we start through this, the first value we're going to write is at nums1 of index 7, right? Well, there is no nums1 at index 7. There's
or
0, 1, 2,
0.
3.
Yeah.
Right. So we have 0 values. And so really what this is going to look like with null values or 0 values in it is basically this. And so I'm taking this value here and I'm saying, should I put in A or B, right? Which one's larger? And so as I go through, this is, if we do a comparison between the two, 4 and 8, which one's bigger? We're going to put 8, right? And so 8 goes here, and then my B value gets subtracted 1, right? We're in this scenario. And so now this index is going to look against this 7. I'm still looking at the 4 for here because A never changed. And so I subtract from my right index 1. So the next value that I'm looking to change is going to be 6, right? And so I'm now changing this value, and I'm now looking between 4 and 7, right? And so B is going to be bigger. This turns to a 7. We do the same thing. This drops to 1. this is going to drop to, I think we're 5 now. 5. And so we do the same thing, 4 and 6. This turns to 6. We do all of this, they subtract. And now we're at 4 and 5. 5 is larger, so it gets here, right? So these have all been handled. B has gone to -1, right? And that terminates this loop.
Yep.
And so
Yep.
now we're in the scenario where you have 1, 2, 3, 4 from A, and then the rest of these for B. And so
Cool.
in this scenario, there is no option to overwrite a value because at each iteration, we're going back one index from the right index,
Mhm.
as well as for the individual A and B indexes.
So that was really helpful because, I mean, would you have had to do something like you just talked through if you didn't know the optimal solution already?
To determine the optimal solution,
Yeah, yeah. Or is this something that you feel like, if you've seen a question like this before, you get little hints, like the fact that they've already put zeros in the places at the end, so you're kind of getting a hint that you're not going to have to do any replacements or something. Like, how did you know?
yeah. So there's always this idea of like most people's first thought. The typical first thought is like the brute force technique.
Hmm.
And brute force usually ends up in some exponential algorithm, right? It's easier in someone's brain to say, well, like I'll just iterate over nums1, and then for each of those values, I'll iterate over all the values of nums2, right? And
Yeah.
so for like the first value, I'll iterate over all of these and see where, like if the first value in this matches or something. And so you can solve the solution that way, right? And you get to a working solution, and now nums1, because you've compared every value against every value, you can check to see if it's greater or less than, right?
Hmm.
And then comes the point where the question or the interviewer asks, like, what is the space complexity and what's the time complexity, right? And you're saying, well, it's m times n squared, right? Like I
Hmm.
have to go through each value every single time. And so they pose the question, well, is there a way to optimize this? And so now you start thinking, like, I have a baseline of m times n squared. Um, and like the general, like the fastest we could do something is constant time, right? So they talk big O notation. How quickly can this algorithm run, regardless of scale? With these
Hmm.
arrays where, a million each, uh, uh, running something that has 4 exponentially might be a couple milliseconds, but if you put it to a million, it's now taking several seconds, and you're worried about timeouts
Hmm.
for like endpoints that you have. So the idea is like, is there a way to do this in constant time? A lot of times with constant time functions, there's a like calculation, right? There's a mathematical equation that lets you do something once to do it once, right? Um, Most of the time, that's not a realistic solution for me. And so I start thinking, can I do this in linear time? Is there a
Hmm.
way I can step through the values only once to achieve these results? Meaning, can I do a comparison as I step through both arrays at most one time? And so at that point, I start thinking, um, I need to have some representation of an index at both places, right? And so there's this concept of like a 2-pointer system, and so you have two different indexes, 2 pointers that reference some spot in this array, and I can do comparisons of those, and I have to be able to shift these each time I do a comparison. I have to go backwards. I have to subtract, and if I know that I can do that, right, I have these 2 different indexes, and each time I loop through some iteration, I subtract one. And if I subtract one at each iteration, that in my head is signaling like this is a linear type of solution,
Hmm.
whether it's going forward or backward. And so I play around with the idea of like, well, if I go forward, um, I don't even know if I went through when I originally went through this. I thought about going forward, and I don't know why. It might be because I referenced this previously,
Yeah. Yeah.
um, and so
That is.
that kind of it was like uh, when I say go through these to get the optimal route. It's so the next time I attempt it, I don't have to do the brute force part.
Yeah, yeah. You can identify, oh, this is that two-pointer situation. Like, okay, I've got
Correct.
two arrays. I need to probably keep track of the index in both arrays, and that'll get me closer to linear time.
Those are the
Yeah,
things I think about first when I approach
yeah,
these problems. I immediately think of, I have two arrays and I'm trying to iterate through them. That to me immediately sounds like a two-pointer situation.
cool. Okay,
Um, and so
now,
that's like where I off the bat, that's what I start with, the
now,
concept.
can I ask you what would happen here if nums one was 5, 6, 7, 8, and nums two was 1, 2, 3, 4? Would it work in the same exact way?
Oh, if these were flipped,
Yeah. So if
it would, but we can step through it if you want.
yeah, I'm just curious if you try to take a look at something like this, you've found the optimal solution. Do you go one step further and try to mess it up a little bit? Like even further than they're doing in the different examples on the left. Like because I know that in some interviews that I've been in, even after solving the solution once, they might say, okay, well, can we do it a little different way? Or like, what if this was 10 million items? What would be different here? Like things like that. So
Mhm.
if you do something like this, does it change in any way?
It doesn't, and so we end up in the same, right. This starts at 7. So the first one that we're trying to go through, we're now comparing 8 and 4, right? So we are going to take, um, so as long as we have a b value, which we do, right? This b index is greater, and we have an a, the index for a, we have some values left to actually process through a. So if the a value is greater than b, so if a value is greater than b, which it is, we take this 8, right? So the very last value in this, um, if we think about it this way again, we now have it as 8, right? And then we're going to step down to 7. And so now we're comparing 7 and 4 until 7's bigger. And so we go to 7, we subtract a, similar how we did with b, right? And this still
Mhm.
remains 7 because we're going to eventually overwrite it. The right
Mhm.
index is going to step through all of these to get to where we want to go.
Mhm.
And so we go through the next one, which is now 6. And the next one is going to be 5. And at this point, a is going to be -1, right? This is what terminates that spot. And
Mhm.
so a is no longer greater than or equal to 0, but we do still have a b. And so we need to step through all the b's now. And so it iterates through, and obviously this is not going to pass the conditional. So it now jumps down to this value, which is going to be 4. And so it
Mhm.
changes this to, the 4. And the same thing, the next one, as we drop b down, the next index is going to be 2, which is the third value, and then 1, which is 2, and then 0, which is 1.
Mhm.
And so there's not, uh, this is it, right? Like
Yeah.
this is the optimal solution. There's not it's at linear time. So once I
Yeah.
get to linear, now it's like, is there a way to do this in constant time? Um, no, they're just simply not.
Yeah. Yeah.
For some questions, there might be, right? There's some equation that can solve certain things in constant time, right? You just do it once and you solve for the whole problem. But if we're talking about any type of scenario where we have to check values against one another, the only way you can do that is through iteration. And
Mhm.
so linear in this scenario would be the quickest way to do it. And
Cool.
so I would talk through and say, like, this is at linear time. This is as optimal as it's going to get from a time complexity. There could be ways to handle this maybe with space complexity. So meaning like how many new variables are you introducing as you go through?
Mhm.
But we're only introducing 3, right? These get manipulated along the way. We don't instantiate what A is to to new pieces in space. And
Yeah.
so we're just changing what the values are. And so like this would be it.
Well, now, so we could go on this one, but now for your practice purposes, would you have started taking a look at this? Let's say it's been a month or two since you did this last. You kind of are working on like active recall where you're about to forget this optimal solution. So you come back in. Would what we just did be the way that you would practice this, or would you try to write it from scratch, or what?
What we just did was exactly what I would do. And it
Cool.
has been maybe, 6 weeks since I've looked at this problem.
Cool. Cool.
So that's exactly what I do. Like I took a look at it, when I first thought about it. It's like I've seen this problem before. I've seen the concept before. I don't quite remember what I did to solve it. And
Mhm.
it took me, I don't know, a few seconds to think, okay, well, I've got 2 pointers. And if I have 2 pointers, the only way to tell if something is going in the ascending order is that I have to find the max values. Um, and so it triggered me to think, well, look at the end because that's where the max values are. And then it came back like fairly quickly.
Mhm.
Um, and it's more just like retracing what I've done a while ago.
So did you want to look at another problem this morning, or do you want to keep going on this
Yeah,
one? Okay.
we can go through like one that I don't have, um, one that I don't have code for.
Cool.
And so, like again, I'll read through the problem, and then the way that I do this is going to be a little bit different. And so we can step through that in a second.
Here, why don't
So
I can read through it a little bit while you think about this.
yeah,
So okay, remove duplicates from sorted array. This is a medium problem. So we have an integer array nums sorted in non-decreasing order. You're going to remove some duplicates in place such that each unique element appears at most twice. Each unique element appears at most twice. The relative order of the elements should be kept the same. So we're removing duplicates in place. So unique elements appear at most twice, and the order of the elements should be kept the same. It's impossible to change the length of the array in some languages, and so you must instead have the result be placed in the first part of the array nums. More formally, if there are k elements after removing the duplicates, then the first k elements of nums should hold the final result. It does not matter what you leave beyond the first k elements. So return k after placing the final result in the first k slots of nums. Do not allocate extra space for another array. You must do this by modifying the input array in place with an O of 1 for extra memory. So what are some of the things you think of, and what would you typically do?
Yeah, we're in a similar situation where we're not introducing more, space complexity. We want to be able to manipulate things within the existing arrays that we have. And more specifically, you're not supposed to introduce more arrays, right? You don't want to return some new array. And so we're sorting again in non-decreasing order. So we have this ascending order that we're returning something in. We have to be able to keep track of duplicates. Given an array of duplicates, such that. So these are already, the relative order of the elements should be kept the same. So they're already going to be in this sorted order, which again, to me, starts pointing towards like a 2-pointer situation, right? And so I go to some value, and then I check the next value, but I still have to keep track of where the first one is to see if they're the same, right? And I can check each, like if I have multiple of these, because the goal is to find ones that have, first of all, duplicates, right? If it's not a duplicate, if the next value at that index is not the same as this one, I move both indexes over, right? And so I go from 0, and if 1 is not equal to 0, I go to 1. So now I have 2 indexes are sitting at 1. If I'm at 1, say the value at index 1 is 1, and the index value 2 is also 1, I now have the second index that has the ability to start moving forward until the next value is there, right? So, and the goal would be that we can replace, I basically have one index that's checking future values, and I have another index that represents where I am or where I should put a value at.
Hmm.
Meaning, like at some point, if I have multiple ones, I finally hit a two. At the most ones I can have is two.
Hmm.
And so I will move that first index, which was my placeholder. I can move it up as long as it's not greater than two. I guess once I hit the third one,
Hmm.
that's where I want to take my second index, which is up in the future, up further up in the array, and I can pull that back to this spot, right? And so now I've overwritten one of the ones with the next value.
Cool.
And so the concept here is like I see this two pointer thing happening again. And so the way that I approach this is I do that, right? I think of some concept that makes sense to me to where it reasonably would try and solve this. And this just comes from repetition, right? You do enough of these, you start to develop patterns. It's pattern matching. And so I immediately, like, I see the problem. I have some general idea of what I would do. I go look at the solutions. And so I won't even write code yet. And so, like, you can see the tags up at the top. And Python 3 is where I go for a tag that gives Python 3. But I immediately see other tags that say like two pointers. And so I know I'm somewhat on the right track. And so here's one that says the two pointer approach. And so, you know, I'm basically not trying to reinvent the wheel.
Yeah.
Somebody has solved this problem, whether it's on LeakCode or otherwise. And again, this is practice. So it's about developing the patterns and recognizing them.
Hmm.
And so this is in constant space complexity, which is what we want, in linear time complexity. And so we already walked through if something's iterating, you're not going to get to constant time doing that. And so this would be as optimal as you can get, right?
And
This type of solution.
just to be clear, when you said it's constant space complexity, which is what we want, because they said you cannot create a new array, you need to keep exactly the same array. So that's not increasing space complexity.
Yeah.
Cool.
And even if they said you could, if I have the option between one that is like linear space complexity, meaning we're adding new variables through each iteration, the fact that this says it's constant space complexity is going to be better anyway.
Mm-hmm.
And so you at constant anything, whether it's time or space, like that's optimal. You're not going to get better than constant. And so this, just from like an output standpoint of time and space complexity, would be an optimal solution, regardless of how they do this in here. The second part to me is like, is this something that you can explain to an interviewer and it makes sense, right? Like, and some of that goes into naming variables correctly, the structure of it, using the ins and outs of the language correctly. But that is almost secondary. I think by talking through problems, even if the code looks a little messy, if you explain it correctly and somebody can follow along, that's something you can go back and fix and refactor.
Yeah.
And so if I look at this problem, they're instantiating some variables. We have L and R, which I'm assuming are left and right, an account. And so we have 0, 1, and 1. And so while R, which is the right, is less than the length of nums, meaning that R is going to be the one that we're traversing all the way up, right? That's the one that's checking like future values. As long as we have another value to make R increment to, we can go through this loop. And so that's kind of where our breakpoint is at. If the nums of R equals to the nums of L, meaning that the two values are the same, the two pointers, and count is less than 2, because you can have up to 2 at each value, right? More duplicates is bad. Then if it's less than 2, then you can move left over one more, right? So we can basically say, like, you can have duplicates, but I'm going to keep L and R. I'm going to move L and R up until L is at the max duplicate value, right? And so now it means the next placeholder that I have, I've already accounted for the max amount of duplicates that I have. And so we increment L. The nums of L is going to be the nums of R because they were the same, right? That sounds right, because R might be, I'm wondering if you even have to do that part. Nums of L is equal to nums of R, but they're already the same. So you might not, I'll come back to that. I don't know why that line's there yet.
And count is less than
And
2.
then,
Yeah. Okay. Yeah.
and so we increment count, right? And count is determining, have you reached your max amount of duplicates for this given value?
Hmm.
And then we have an else if nums of R is equal to it, but the count is greater. Then we add count plus equals 1, but we don't move the indexes. And so we're basically going to let R continue to move forward, which we see down here, to
Hmm.
find like where the next non-duplicate value is.
Hmm.
So we're basically anything in between that, we're going to end up overwriting. And so it goes down into the else, which is the scenario where it's a different value, right? They're not the same. And so you increment count. Count is equal to 1 because you have one of the next value. Left moves, and then the left value becomes whatever the right value was, right? Because it's a new value. And so now you're constantly going to be replacing what the next value is. And so the only part that didn't like immediately jump out to me as making sense is this one here because the values are already the same.
Hmm.
And so what I would do is just take this. And so the goal for me isn't just like, here's the code, submit it, and it's submitted. Like,
Yeah.
I want to understand why it worked, or else it's pointless, right? And
Yeah.
so far, like I've had some concept and idea. It matched what a solution was that was optimal, which is great. It's not always that case. And then like understand the code. And so for me, like I would run this obviously just to make sure that it actually does run correctly. And then this, because these values are the same, I almost just want to see if this does what this does. And so this does break it. I had a 2. And so at some point, so we go 0 and 0, those are fine. 1 and 1, we've replaced. The next one that goes through, which is this 1, hits this conditional. And so we move this value to here. And then right is going to keep moving to the 1. And at some point it hits the 2. So they're different now, which is going to hit this. And so this value now becomes the right. So the 2 jumps into the 1 spot. We jump everything to this 1, where the right now grabs the 3. And so it makes it a 3. And then left jumps to this spot. Okay, so that's why it's doing it. So I see where the problem is. If I don't add this in, as my left moves forward, it's going to hit a number that it hits a number that left is going over to, but the right value is the one that we're supposed to be using because we have iterated over duplicates, if that makes any sense. Like at some point, left is going to hit 2.
Hmm.
And as left hits 2, the right value is actually pointed at 3. And so it handles cases where you're going over a value that got changed.
Yeah.
Because that left index is in the past, it's behind.
Yeah.
And so by having this, it makes sure that any value where the left is something that we have already skipped over or we've already handled, because the value at the index of R or right is the actual values we want to use.
Hmm.
So right is always determining what the value is. Left is just choosing the placeholder of where we put it.
So like even when there's duplicates, even though there's not actually a difference between the two numbers, you still want to do the replacement.
You do the replacement because it rewrites the value that's already there, even if they were the same.
Yeah.
But it handles this case where the left index is stepping over something you've already processed. And so by doing this, you're reassigning a value to what it already was in some cases, but it handles the situation where it was not that.
Hmm. So is the reason this would be medium, whereas the previous one would be easy, is the fact that you have to keep up with the count in this situation?
Yeah. So it's very similar. Like one is the first one was like take these two things and merge them, and this one is it's like take these two ideas and add something on top of it,
Hmm.
right? Like go through this array, find duplicates, but they can't be more than two,
Hmm.
right? Like
Hmm.
there's this third piece to it, which adds a bit more complexity because you have to handle that one scenario.
Cool.
They're not that much different, but um, there is like one more piece that you have to think about in tandem.
Hmm.
And so I would submit this, and now this would go into my bank of questions that I end up reviewing, right? So the
Yeah.
next time I look at it, and I try not to look like I won't look at the same one the next day.
Yeah.
I'll go pick like a random one somewhere else, right? Like I'll just pick one, and that way I can space it out a little bit. And like with the merge sorted array, it's been 6 weeks or so since I've looked at it. But the fact that it came back, it's an easy problem.
Hmm.
But the fact that it came back so quick means that the retention is there,
Yeah.
which is what I care about.
Cool. Cool. And do you just kind of keep these in your head? Like you'll come back in a few weeks and be like, you know what? I haven't done that count one in a while. Let me find that.
Yeah,
Okay.
yeah, pretty much.
Cool.
There will be like one weekend where I'll just step through them all. Like
Okay.
once every 2 months or something, I'll go through each one, the ones that I've done, and just basically review them. And so as
Cool.
long as I can remember those concepts, that's the part that I care about.
Well, awesome. Well, I know you gotta get to work. Anything else you would typically do to wrap up before you?
That's that's it. This is
Cool.
like my morning routine. I'll do like an hour of this a few days a week, um, and then hop into emails and start my day.
Yeah. Awesome. Awesome. Well, Dylan, thank you so much for walking us through this. Like that was really helpful for me. Honestly, it's been a while since I've looked at challenges like this, and today we talked about like the 2.0 solution, which jumped out at you both times. Maybe we can do this again in the future. And we'll look at something where you have to use a different one of those types of things that jump out at you, like a hash table or something that might be a different one of those. Like, oh, this is this. You know.
Yeah,
But
yeah,
yeah. But I really appreciate it. And yeah, thanks for your time.
awesome. Thanks, Kylie.
I hope you like this, and if you did, please consider subscribing and let me know in the comments what I can do differently, what you'd like to see so that I can improve these for you next time. Thanks.